Okay, Assalamualaikum and good day. So for now, we will look at this example. Okay, given the graph of fx as below. So first we need to find the function of fx and b find the Fourier series of fx. Okay, we need to find the function of fx as given to us. The lower boundary is negative pi and the upper boundary is pi. So from here, we know that the period is actually pi minus pi. So here 2L is equal to 2 pi. So by right here L is equal to Allah Akbar. L is equal to pi. Okay. So that's the first one. That means we know that one period is equal to 2 pi. Okay. Next, we want to find the function for this particular graph. So right now, we need to determine first either it is an odd function, even function, or neither. Okay, to help us to solve this question. Okay, so for now, let's test it for even function. Okay, for even function, we know that it need to be symmetry at the y-axis. So as you can see here, this line, okay, let me point out using the highlighter. This line is actually symmetry. Okay, symmetry at the y-axis. And then we have another one. This line is also symmetry at the y-axis. Okay. So therefore, we can conclude that fx is an even function. Okay. Since it is an even function, we will be using Fourier cosine series. Okay. That's it. Okay, that is another way. Since whatever it is, we still need to determine the fx for this function, right? So fx is actually equal to, okay, from negative pi, x between negative pi to negative pi over 2, it is equal to 0. And then 1, when negative pi, x between negative pi over 2 until pi over 2. And then 0 again when it is between pi over 2 and pi. Okay, this is the function for fx. Okay, as you can see here, see the same one. Okay, so from the graph, as I explained earlier, this is an even function because it is symmetry at the y-axis. Okay, so next, since this is an even function, therefore Bn is equal to 0. Okay, Bn is equal to 0, so we just need to determine A0 and An. Okay, I've explained to you why L is equal to pi. So, right now A0 is equal to 2 over pi from 0 to pi. Why 0 to pi? This is because we are going to find it as half range. Okay, only half of the function because it is symmetry. It doesn't matter if we find from negative pi until pi. It's just going to be 2 times when we integrate from 0 to pi. Remember, integrate negative L to L fx with respect to x is equal to 2 of 0 to L fx dx if fx is even function. Okay, that's why you're gonna just use the function for half of the fx. Okay, so right now this one can be expand into 2 pi, integrate from 0 to pi over 2, the function is 1. And then integrate with respect to x plus 2 over pi, integrate from pi over 2 to pi, the function is 0 with respect to x. Okay, so since this one is 0, you don't have to calculate because this is 0. So integrate 1 is equal to x. So substitute the value from pi over 2 to 0. That means pi over 2 minus 0. Okay, this one, we get the value for A0 is equal to 1. Okay, next, A of n is equal to 2 over pi, integrate 0 to pi, fx cos nx with respect to x. Okay, why cos nx? Okay, I would prefer if you can write this first. Okay, an is equal to 2 over l, that means 2 over pi, integrate 0 to pi, fx, okay, cos n pi x over pi, because l is pi with respect to x. So next, simplify, cancel out pi. That's why That's when you have this equation transform into here. 2 over pi integrate 0 to pi fx cos and x with respect to x. Okay. And then I would suggest you to actually write this function in bracket. Okay. So right now, we will integrate. Okay. Because you might not see it here. Okay. So right now, 2 over pi integrate 0 to pi over 2, 1. Because fx equal to 1 times cos and x with respect to x. Plus 2 over pi from pi over 2 to pi, 0 times cos and x with respect to x. Since anything multiplied with 0 is 0, so this part will be 0. So integrate cos and x is 1 over n sin and x. Okay, as I mentioned earlier, I would prefer if you write it like this. 2 over pi, open the bracket. Okay, differentiate n x will be n, so 1 over n. And then integrate cos n x is sin n x. Okay, 0 pi over 2. Then only you substitute the value. Okay, so right now you have an is equal to 2 over n pi sin n pi over 2. This one equal to 0 is because sin 0 is equal to 0. Okay, therefore the Fourier cosine series is defined as fx equal to a0 over 2 plus summation n equal to 1 unto infinity a of n cos n pi x over l. So L is actually pi. So cancelling pi, by simplifying, we have here cos nx. Okay, so just substitute a0 that we obtained earlier is equal to 1. So that's why here is 1 over 2, a0 over 2 plus summation n from 1 to infinity. Just substitute an that we have obtained earlier. Okay, and that's all for this example. Thank you. Assalamualaikum.